Hi, welcome to this lesson on algebra logarithms, using logarithms to solve equations part, question 6. Solve for x here. Again, this looks like a quadratic expression, a trinomial with 3 terms, and I see a square inside there. So, using k substitution, I would say let k equals this number inside the brackets. Log base 4 of x squared. Now this isn't log base 4 of x squared, but I can make it look like that by using the power rule and bringing the 2 there. So therefore I get log base 4 of x squared all squared plus log base 4 of x squared minus 6 equals 0. Using k substitution, that becomes k squared plus k minus 6 equals 0. Factors of 6 are 1 and 6, 2 and 3. Most likely to give me a difference of positive 1 would be 3 minus 2. So therefore, if I try factorize this, it's going to be k and k, positive 3 and a negative 2. And if you expand that out, you'll see you get the correct quadratic expression that we have here. Therefore, using the 0 law, if I equate that to 0, k must be negative 3, or equating that equals to 0, k must equal 2. But what was k? It was log base 4 of x squared equals negative 3, or log base 4 of x squared equals 2. Now, don't be alarmed here that we have a negative answer on the right-hand side of the log. The important thing to remember is that the log of an input, this number here, cannot necessarily be negative. Okay? But the output, when you put in a number, can be negative. And you'll see that from the logarithmic graph when you draw functions for logarithms, which are the inverse of exponential functions. But observing this original expression, it's good to note that, could x be a negative number? Well, here it can be, because when you put it in, it's going to get squared and it'll become positive. So that's fine. But what about this guy here? Now, if I put a negative input into there, we have an issue, because that log cannot take a negative input. So therefore, if we do get negative solutions, we have to dismiss them, because the original equation can only admit positive solutions. Let's look at this one. How do I get x squared by itself? I take the base and I raise it to the exponent. So 4 to the power negative 3. Or, same here, how do I get x squared by itself? X squared is equal to the base 4 raised to this exponent 2. So therefore I get x squared here is 1 over 4 to the power 3 using exponential laws. But that's 1 over 64. And 4 squared is 16. Now because this is x squared, you will get two solutions. If I square root the right hand side, it becomes plus or minus 1 over 8. And if I square root this side, x becomes plus or minus 4. But we said originally that the original expression cannot admit negative solutions. So we say, but x has to be greater than 0 because of that 2 log base 4 of x term. So therefore, the final solutions are x equals positive 1 over 8 or x equals positive 4. And we can check these solutions. So the first one was a bracket squared, plus 2 times log base 4 of the number, minus 6. Inside the brackets, it was log base 4 of some number squared. Check we got that right, yeah. So the first solution we put it in was 1 over 8. So let's go put it in there. 1 over 8. And pressing equals, we get 0. So that is definitely a valid solution. What about when x equals positive 4? If I put in positive 4 here, it's going to become 0 as well. Let's try put the negative solutions that we worked out in and see what happens. I put the negative 4 there, and I put the negative 4 there. Math error. Because what is happening is that the second term is returning an invalid input, right? You are putting in a negative number where it shouldn't be for the logarithm. Hence, it would not give you a solution. All right, and that's how you would solve this equation using logs. I'll see you in the next one.